Today we're going to be learning about long division of polynomials and more importantly something called synthetic division, and sometimes it's written as synthetic substitution. So our goals are to divide polynomials by other polynomials and use synthetic division to divide polynomials of the form x minus r. So the first thing I'm going to do is show you a long division of a polynomial. We will not be doing homework on these, but I want you to be aware of what it looks like because it will come into play again next year in your tricking pre-calc course with Mr. Roach. So let's look at this first problem. If you are asked to find 3x cubed minus 2x squared minus 13x plus 14 divided by x minus 2. The very first thing we would do is set up our long division problem. And so we would write 3x cubed minus 2x squared minus 13x plus 14 divided by x minus 2. This will remind you of something that you had in grade school when you did long division. So we're going to transform and divide x into 3x cubed, and then we need to multiply 3x squared by x minus 2 to continue. So we're going to go ahead and take 3x squared and divide that into and multiply 3x squared by x minus 2. So that's going to look like this. So if I divide, I'm left with 3x squared. Over here, after I multiply, 3x cubed minus 6x squared. I'm going to go ahead and perform that problem. And I have 4x squared. And I'm going to bring down the rest of my problem from here. So when I bring that down, I have negative 13x plus 14. And we're going to continue. Now that we have that remainder, we need to follow our first step again. So I'm going to take my 4x, which is here, and divide x into that. So I will have plus 4x, multiply it by the x minus 2, and then I will have minus 4x squared minus 8x. Go ahead and do that math problem. And I'm left with negative 5x plus 14. So for the last step in our long division, we need to get rid of our negative 5x. So we're going to take minus 5 times x minus 2. And we will subtract our negative 5. Then we will multiply that across, and we have plus 10. And I will be left with a final remainder of 4. So this right here is going to be my final remainder. And so the answer to a problem like this would be written in the following form. 3x squared minus 2x squared minus 13x plus 14 divided by x minus 2 is equal to 3x squared plus 4x minus 5 plus 4 all over x plus 2. And so this is a proper fraction because the numerator is a lower degree than our denominator. And so that took us quite a few minutes to go ahead and solve it that way. And so in our course, instead of spending time going over these, we're going to learn something called synthetic division. And I'm going to solve this same problem in that manner. And so if I have my same problem of 3x cubed minus 2x squared minus 13x plus 14 divided by x minus 2. I'm going to set it up a little bit differently than long division. And so when we set up this synthetic substitution, it's going to look like this. I'm going to draw a little box. And when we divide, we always want to make sure that we're using the root associated with the divisor. In this case, that root is a positive 2. So I'm going to put a 2 outside. And then I want to make sure that every single variable is represented. And in this case, we have a cubed, a squared, and an x to the first, and a 14. So we don't need to put in a 0 for any of our x's that are missing. So what we're going to do then is write the coefficient directly in front. So we have a 3, we have a negative 2, a negative 13, and a positive 14. So all I've done is take the divisor. Here, this x minus 2, it's actually a positive 2 when we take the associated root. And then we're going to take the coefficients from in front of our variables. Now here's the easy part. We're going to go ahead and take our 3 and just bring it down. So when we bring our 3 down, we have him here. So we're going to take 3 times this 2 and then place that value here, which is 6. We then are going to add down the columns. Negative 2 plus 6 is a positive 4. 4 times 2 is a positive 8. Negative 13 plus 8 is a negative 5. Negative 5 times 2 is a negative 10. Positive 14 plus a negative 10 is a 4. And now this value here is our remainder. That guy's really important. So we can go ahead and write the solution to this problem as 3x squared plus 4x minus 5 plus 4 all over x minus 2. And if you notice, the problem we did before, we had the same solution in long division, only using synthetic substitution, it is a lot less time consuming. Let's go ahead and look at another example. So, if you are asked to do the following example, x squared plus 5x plus 6 divided by x minus 1. We're going to go ahead and draw our synthetic division box. And we want to make sure that we have our divisor. So it's x minus 1, so a positive 1 is written outside of the box. We then are going to fill in our coefficients. For those of you that are asking, Mr. Rockman, where did you get that 1 from? Remember, there's an understood 1 in front of the variable x squared. So we're going to go ahead and bring that 1 down. When we bring that 1 down, we're going to multiply 1 times 1, which is 1. 5 plus 1 is 6. 6 times 1 is 6. 6 plus 6 is 12. And this, my friends, is my final remainder. So this final answer would be written as follows. X plus 6 plus 12 all over x minus 1. For those of you that are confused on where that x is coming from, I'm dividing x minus 1 into this polynomial. And when I divide those, I end up with x plus 6 plus 12 all over x minus 1. Let's go ahead and do one more example. And this one is a little bit more challenging and is the picture I posted on Moodle. So for this one, if you are asked to take 2x cubed minus 5x squared minus x plus 3 divided by x plus 3. We're going to set up our synthetic division box as follows. Notice x plus 3, we want to take our root associated, so it's going to be a negative 3 out front. We're going to go ahead and fill into our box each of our coefficients. We're going to go ahead and bring down the 2 right off the bat. So 2 times a negative 3, a negative 6. Negative 6 plus a negative 5, negative 11. Negative 11 times a negative 3 is a positive 33. Watch your sign there. When you add those together, it ends up being 32. 32 times a negative 3 is a negative 96. So then we're going to have a remainder of negative 93. That's a large remainder. And so this final answer will be written as 2x squared minus 11x plus 32 plus negative 93 all over x plus 3. And again, that's a proper fraction because the numerator is lower degree than the denominator. So, again, the whole point of this synthetic division is to be a shortcut for dividing polynomials by a binomial in the form of x minus r. You will see this again next year in pre-calculus. So please make sure that you have an understanding as best of your abilities at this point. Please complete the homework on Moodle, and if you have any questions, please reach out to me.